Okay. Good morning. Good morning, everyone. Yeah, thanks for joining us today, this morning at for Nippon Paint Talk. So yeah, we are from SIDS and we are organizing the Singapore Interior Design Festival. So we have invited Nippon Paint to, which is one of our sponsors, to give one of their talks at SIDFest. Yeah, so without further ado, let me welcome Ms. Lin Lee, Senior Advisor of Nippon Paint, to share her talks on the myths in the difference in colors.
Hi, good morning, everyone. Thank you for joining us at this session. This session speaks about the myth of color difference. We hope to share with you on the understanding of why color differences come about, and hopefully you'll be able to use the information we've shared here to avoid color difference, even though they appear to be the same. But at the end of it, when you installed it, it will be different. All right. So without further ado, let's first and foremost understand the physics of what we call color theory. All right. We all use colors for some reason or other, but essentially the purpose of using colors, especially when we paint our homes, our offices, is to improve aesthetics, is to beautify the place so that we feel more comfortable in it, or we feel more happy or joyful in it. All right. Second purpose of having colors is that some colors actually suggest thoughts in each and every one of us. Our human brains have been kind of like indoctrinated in some way. So, for example, a very typical example that comes off my mind would be blue and pink. You know, blue would denotes the male, and whereas the pink denotes female. So, for example, when we want to color a forthcoming baby, if we know that the baby is a boy, we will perhaps want to have things that are more blue and avoid pink, for example. Some public toilets are actually colored blue to denote that this is for the males, and then the pink for the female. All right. And also colors are to represent statement or a message, whatever. For example, we use red to caution people, you know, that of an impending danger or something. And some colors actually influence our mood. This is under the psychology of colors. So perhaps when we want to have to stimulate a discussion, stimulate appetites, we use what we call the very warm colors, the reds, the oranges, to influence our our mood. All right. So that's the purpose of colors. Now, how are colors formed? Basically, we have to understand that when we see colors, it is what is reflected into our eyes from the lights. You know, the whole spectrum of lights reflects different kinds of wavelengths, so we see all the different colors. Right? Some terminologies on colors. The hue represents what we call the pure colors, the pure reds, the pure whites, the pure reds, the pure blues, greens, and yellows. Whereas when we say shade is when we add black to these hues, right, to the actual colors. So they tend to be darker. And when we add white to them, we call them tints because they become lighter. Tones are when we add gray to the hues. So generally the colors becomes more dull, more less what we call it bright in its, or less fresh. So the tones are when we add grays into it. So this is primarily a color wheel to show the basics of colors differentiation. For example, primary colors are basically red, yellow, and blue, right? The red, yellow, and blue makes up what we call the primary colors. And mixing these colors will derive another range of colors, which we call secondary colors. So most of us know about this, all right? For example, red and blue, you mix it, you become purple, or what we call violet. Orange is a combination of red and yellow, and a combination of yellow and blue gives you green. So secondary colors are what we call subsets of the derivative of mixing primary colors. The color gamut makes up of all the colors that we can see with our human eye. So as you can see from this color gamut here, colors mixed with using what we call colors CMYK, the color range is a lot narrower than if you were to use RGB colors or what we can see with our eyes. This is because the nature of mixing these colors only can provide us a certain range. So it's not the complete range of colors that we can see with our eyes. Okay, so now how do we arrive at colors? How do we, mix colors? So there are two ways of mixing colors. One is by additive color mixing, and the other one is by subtractive color mixing. So what is additive color mixing? Additive color mixing is basically adding one wavelength to another wavelength. So the mixing of different sets of color wavelengths will give you different colors. And these are used basically in colors that we see in our monitor, projector, or feature lights, basically on electronic appliances. All right, and combining all these wavelengths together will give us white. Okay, so as you can see here, combining all the wavelengths, you can see here it will be white. Now, subtractive color mixing is the direct opposite. It's the removal of wavelength from a light spectrum. So in the mixing of paints, dyes, or any form of colors that we used, right? It will is basically the removal of these wavelengths, and these are used, as I mentioned earlier, in the mixing of paints or dyes or in the manufacture of pigments, right? And combining all these colors, all right, all these colors, or removing all these wavelengths, for example, will give us what we call black. All right, unlike additive, it will be white. This one, it will be black. So as you can see here, our eye is the tool for us to perceive the colors, all right? Our eyes help us to see what colors that is in front of us. However, it is not sufficient. There is still some what we call a deficiency in our human eye. They can be due to many reasons. Some of them could be memory loss or fatigue, viewing in a different condition. And so we sometimes see different colors at different times, right? And color differences also, I must add, is difficult to quantify or difficult to communicate. We say, oh, slightly darker or slightly darker, and some people have said, how about 10% darker or 20% lighter? It's difficult to communicate, all right, because this is not what we call a proper measurement of color difference. All right, so as I mentioned earlier, these are the factors, the whole gamut of factors that can influence what we call or affect our color perception and therefore color accuracy. So here I will go through some of them visually. So color deficiency is one of them. So some of us do have some form of color deficiency. We may not be aware of it unless we subject ourselves to some color tests. But there are some people with very severe color deficiency. They are what we call color blind. So they can only perceive colors within a very narrow spectrum. So sometimes they can't see red. So they see red, as you can see here, as a greenish yellow. So they see mostly this kind of colors. They do not see the hues and that we can see, that a natural eye can see. All right. So these are basically people who are colorblind. All right, they can be red green colorblind or blue yellow colorblind. So yeah, so and to be what we call in the paint manufacturing context, when we want to be call it a color matcher or a color specialist, we need to pass a certain test. For example, what you can see here, these are the 4 different colors that are arranged from lighter to the darkest within the same shade. The green, all right, they may be green, they can be blue, they can be purple or orange. So they are arranged in what we call the light to the darkest, and there are 100 of these pieces in each color palette. All right, and we are supposed to arrange from the lighter to the darkest in that range, from the lightest of green, for example, to the darkest of the green. And there are 100 of them, and you need to pass this test to be able to arrange them in the correct order. All right. Now, the other thing that can affect what we call color perception or color accuracy is what we call color memory. Now, here I like you to look at the screen for about 10 seconds. Look at the screen now. Look at this color that I have here on the screen, this little rectangle that I have on the screen for about 10 seconds. Just look at it. Right, now you tell me, okay, tell me which color is it? Have you made a guess? Okay, let's see whether you're correct or not. Right. For those of you who chose N, you are correct, okay? But like you say, color memory is such that it plays tricks on us after, after a while. So we may not be able to remember it really accurately. All right, so you can see it is N. Right. The other thing will be the color background. Sometimes the background or the surrounding can affect our color perception as well. So as you can see here, the 2 little circles or ovals of yellow color, they are exactly the same, but if placed on a black background, on a white background, it will look different. So this is what you can see here, the yellow on a white background and the yellow with a black background, so it looks different. So the one with the black background looks a lot more richer, a lot more yellow than the one with the white background. Right, this is what we call simultaneous contrast. It is also has to do with the surrounding or the background, and the reds that you can see here, all right, in this picture is actually the same red, but under a different background, it looks different. All right, it looks more orange. All right, because one is just is against what we call on the yellow, the other one is on the blue, so it looks different. And the other one is the green, so again it looks much lighter. All right, when it's juxtaposed to with against what we call a yellow background. Right, when it's surrounded by yellow, it looks a lot lighter. Okay, so the surrounding or that surrounds the color that we want to see will affect also the perception of its actual color. Right. Again, I'd like you to look at the screen again of these colors. They are actually different, all right? They are different shades of blue. But let's see what happens if we separate them, all right? We separate them, all right? So you can see that the colors are much closer, all right? And at the end, these 4 colors look pretty much the same. The differences is not so great. For those who are more perceptive, you may be able to see some differences, but it is not as great as you were to see it earlier on without this black separator in between. All right. Right. Then we have what we call the retinal effect. Okay, again, I like you to look at the X on the screen. All right, what we have here on the screen is the letter X right in the center of the screen. Please focus on the screen for just a few seconds, all right? Maybe 5 seconds or two. So what do you see? Oopsie. You see that the, what do you call it? The colors have kind of like, switch places, right? The blue on the green on one side and the red now has gone to the other side. This is what we call the retinal effect. So sometimes when we see this one is a green and the other one is blue, after staring at it for some time, when we look away, what we remember could be the opposite. Okay. Right. Another reason for what we call a color difference is the texture or the glossiness of the surface. All right. So this is a sample, all right, a material that has been selected. All right. This is kind of like a particular standards to show that the same color when it's matte will look different when it is gloss. So glossy colors tend to look darker, even with the same color code, with the same type of paint, but we make it into a gloss, all right, it will look darker, right, as compared when it is matte. Okay, and on with the same color painted on what we call a textured finish, if it's a light texture versus a heavy texture, again it will look different, right? So therefore the same color on different types of surfaces will look different. And also if it's made into different what we call gloss level, all right, it will also look different. So in choices of colors, be very careful. Once we see it as matte on for example, a smooth surface, and you apply it on a textured surface, it's going to look different. And it will look even worse or much more different if it is in a glossy surface. I mean, the paint is in a gloss finish. All right. So just be mindful how the color is applied on the various types of surfaces. All right. This one most of us will know. Sometimes colors are affected by the kind of light that is exposed to. Some of us may have this experience. We thought that we have a right in our own bedroom or in our own closet. We think that we are color coordinated, we are matched, in a certain way. But once we are out in the sunlight, how comes the things don't seem to fall together? The color coordination seems to be a little bit off. It's because it is exposed to different light. So for the same color, for example, under direct sunlight, it will look like the extreme picture on the left. All right. Under artificial light, it will look at the extreme picture on the right. And if it's under indirect sunlight, it may look like more yellowish, like the center picture. So under different light, the very same color will also look different. And this is a point of contention in many of the applications of colors. All right, because we do not know. Once we may have selected the color combination under a certain light, but once it's exposed to a different light, maybe at home or whatever, it appears different. All right. So these are the what we call it a chart of the different luminance level that we can find out there in the market, and they are measured by Kelvin. All right, the color temperature we call it by Kelvin. So usually for measurement purposes, we will use the standard daylight, which is the D65, and the color temperature is 6,500. Okay, so this is the one that we will measure as our standard. All right. So an example of this, when we match colors, we have a light booth that can tell us under daylight what it is, what it looks like, under sunlight, or under a yellow light, what it looks like. So there's this light booth that will change by the the touch of a button, and we can see how this the 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 color or the sample looks like under various lighting. Okay. Now the next one is what we call metamerism. Okay. Metamerism is when under daylight color will look like what we can see here, but under fluorescent light it will look different. Okay, basically because these colors are mixed using different mediums. Okay, so this is most common in metallic colors. All right, but just to explain how this happens, what is metamerism is when we mix, for example, the original color is using maybe two pigments. All right, but somehow when we color match it to match that particular color, we can use a mixture of two or even three pigments and still arrive at the same color when we visually look at it under one light. But the moment we move this match color into a different light, it may look different. All right. So remember, colors can be mixed using different pigments or dyes or whatever. All right. So for example, one color, okay, is matched under, for example, daylight, which is basically very similar to the sunlight, and it seems very close. Okay. But the moment we put it under a different light, or for example, a fluorescent light, they may look again different. Okay. So one may look like brown and the other may look similar or whatever, but somehow it is entirely different. Okay. All right. So again, just to show you what metamerism look like, under one light, it looks the same. That means the color is more or less the same, more or less green. And at the other side, okay, you can see that it's actually very different in color. On the right side, I mean. Okay. There are, finishes out there that are what we call special effects. So generally, some of them are derived from using what we call special effect pigments, and generally they are metallic colors, or they are from pigments deriving from metals, right? So we have metallic colors, or we have mica, or we have pearlescent colors. They tend to behave differently under different kinds of lights. All right. So again, we have to be very careful, because they at different angles they will look different. So when we compare colors, we must know at what angles or at what kind of lighting are they compared at. Okay. All right. So metallic pigments, because of the nature of the pigments, they are not regular. All right. And of course, being irregular, they can reflect the light in different directions. So you can see different colors at different angles. So this is a very simplistic way of showing you what we mean by when it reflects off, the lights differently into our eyes, all right, at different angles. So how do we measure color? Right, so we measure color using what we call instruments. All right, so we have what we call the color visualizer, which I will not go into detail. It's an app that you can download actually from our website called the color visualizer, or you can use what we call a more sophisticated color meter or chromometer. All right, where we can see the actual colors using different filters that is present in the chromometer. So you can actually see the colors itself quite vividly and quite accurately, and they can actually measure the colors for you. All right. So there's, different types of gadgets. Some are much cheaper, some are more expensive. Of course, there is the capabilities are very different. All right. Of course, the cheaper ones are quite limited in the capacity in their capability to measure colors. Okay. Of course, there are more expensive ones. For example, the spectrophotometer. Again, there are different types. All right. They are using different types of filters, various filters to measure colors. I will not go too much of this because this is used mainly in the lab rather than by the people out there in the market per se. All right. So again, just to show you that we have different types of equipment to measure colors. Basically, whether they are textures, we use different types of machines. For auto refinish, because mainly they are very glossy and they're mainly metallic. Again, we will use different types of color equipment. All right. So how we interpret or measure the colors is through what we call a chroma color system. So we measure them and we can actually grade them according to where it is in the color spectrum. All right. So we measure the hue and measure the grayness and the black or the tint, the hue, and according to its position in the color spectrum. All right. So there are different ways, different color system out there. All right. Basically, they are plotting what we call the position of the color in the color gamut. All right. So I wouldn't go into detail this one, just to let you know that there are ways to measure, okay, the actual colors through the using of this equipment. All right, and position them in the position like a graph, right, in the position that they appear on this color gamut or on the color system. All right, so they are the CIE. They measure the XYZ, what we call it, axis. All right, or the LAB or the LCH. Okay, so this is it. They extrapolate them in this what we call the exact position that they appear on the color spectrum. Okay, all right. So for example, this is the LCH. So they can pick out the actual color that appears on this color wheel, on this spectrum. So it maybe if it's here, then they will measure what we call the L axis, okay, and the chroma value, which is the C axis, and then the what we call the H, which is the hue that is appearing on this circular axis, okay, the hue, right, which is on the rotating platform, right. Again, LAB is, I think, more easy for us to understand. Okay, again, it measures the lightness. The L, it measures the lightness or the darkness of these of the color, and then the red, which is and the green, moving from what we call the cool to the cool to the what we call it the hot colors or warm colors, and then the B axis measuring what we call the yellows or the blues. Okay, again on the opposite sides, which is the cool and the warm color. So they are measuring basically the position where the color appears, all right, on this LAB space, color space, you're going to call it. And this is used a lot, right? LAB is used a lot in our color matching system, right? When we measure colors, we will probably use the LAB. Now, just to show you something, all right, for example, there are two roses here. One is yellow, and when we measure or we pick up the colors, we will know that it is on the L axis, all right, and on the a-axis is at 8.88 and b is at 54. So we know exactly where it is, all right, in this color space. And for the red, L is 29, all right, if you can plot it here, L is 29, okay, and A is 52, okay, and the B is 2. So it is somewhere here in this color space. So it's basically the plotting of the color. So we know exactly what it is. So this is how we measure the color. All right. Now, for us, we always track what we call the color difference, and we measure color difference by this unit called delta E. All right. So it measures, and basically here we can actually use machines, the same color equipment to measure what we call the color difference. So when we say the color difference is of a delta E 0.2, all right, is basically almost not visible to our naked eye. No, our human eye cannot perceive this difference, all right, when it is of a delta difference of 0.2, all right. So 0.3 to 1, very small difference, very small. And then when the delta E numbers gets bigger, of course the visibility gets more and more, so we can actually perceive the difference much better. All right. So for us, in the paint manufacturing sector, any color difference of between delta 2 to 3 is fairly acceptable. So we can set our color difference range within this. All right. So depending on the type of paint, you might set what we call a lower delta E difference. Okay. For 4 and 6 color delta E difference is basically not acceptable to us already. All right. It's very, very huge difference. So this is just to show that when we measure the delta E 0.05, our QC will probably say it's okay, or 0.1 is okay, and anything that means it is good to go out, when this delta is if so minimal, because it is not really visible at all. All right. Okay. So we have different meters to measure different gloss level as well. So this is our gloss meter. Now, earlier on, you see a black and white cut where we have 2 yellow circles. So within a black background, it looks different. Under the white background, it looks different. So essentially, we also use the black and white background to measure what we call opacity as well. So under the black background, it should be able to cover and look as good as the one in the white background, right? We have also a light booth, as mentioned earlier, to measure, or to look at the color, the behavior of the color under different types of lighting, right? To ensure that the color is correct. Okay, so spectrophotometer is basically to measure and quantify the color. Okay, all right. So I'm here to now take on questions if you have any.
Hi everyone, you may write your questions in the Q&A section or even in the webinar chat. If not, you may click raise hand and I'll allow you to speak so that we can have a conversation with Lynn.
Right. If you have no question, I thank you very much for your kind participation. Right, so we should be ending right now. Thank you very much.